Hello guys, in this video I want to show you how to solve string permutations by changing case. So given a string, find all of its permutations, preserving the character sequence but changing case. So for example, with given input AB7C, our expected output would be a list, right, of different permutations. It means the character is the same, but the the positions of each character is different. So for example, right, AB7C same as input right here, but from the second permutations we start to change the case of A to become A capital B7C. For next permutations we change the case of B, right? Next we change case of A and B. Next we change the case of C, A and C, B and C, and the last one we change the case of A, B, C, right? So in order to solve this kind of problem, we have two approaches, which is breadth first search and depth first search. In this video, wanna use breadth first search, depth first functions. Alright. So for depth first search, I wanna start. Gonna consider different state of permutations, right? So initially the state is empty, we have an empty string. We'll start to build up this empty string from now on, starting with the first character. Right? We start with A, then to B, then to 7, then to C. So the idea here is to iterate for every not iterate, but to recursively building the permutations. Each recursive functions wanna process one character from our input, right? So we start with A. We start with A, right? So our goals at this level is to build to find the first character for the current permutations, right? So for A, there are two choices, which is A and A is capitalize A, right? Okay, we're done with this level. Next level, considering B, our goal is to find the next character for the permutations, right? Character after A. So again, we have two choices, B and capitalize B. So as you can see, for each permutations from previous step, we can make two choices for each, right? So for this we can have two choices here, which is AB and A capitalized B. For capitalized A, we have two choices also, A, B, and A capitalized B. Next level, for 7 we have only one choices, which is 7, and from each of the permutations from previous level, we have one choices, right? AB7, 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 AB7. Okay. Okay, for the last level, we have, considering C, we have two choices, which is C and capitalized C, right? So from each permutations from previous step, we have two choices. So considering this one, we have two choices. C, only one with C added and one with capitalized C added. In these permutations, we have two choices also. C and C capitalized. This one is the same. C and capitalized C. Okay, so that's it for the algorithm. We go in depth first. Actually, while running manually, it's kind of like we doing it in breadth-first travel slow, but actually when in reality it goes in depth first, right? So let's start coding. We have one function takes in a string. Here could be here could be the original string, right? Then we need to decide what kind of state we want to pass between the recursive calls, right? So I'm thinking about we can keep the current index, right? For example, at this level, the current index is 0, which means the first character from our input, right? So with that index, we can access from string the character that we're considering, right? So current index. What else? And we need also to keep track of all the permutations, right? Let's say all is initialized with empty string if there's nothing passing, and current index initial is 0. Okay, so this one, the all variable, we only want to add new permutations when we reach the end of the tree. Yeah. So how do we know that we reach the end of the tree? It is when the current index is the same as the is out of range again. So if current index equal to string.length, it means we're out of range now. So in that case, wait a minute. We probably want to persist the current permutations. Current permutations, right? Is a string. As you can see, we are in this diagram. We are building up our permutations, and we go down the tree. So okay, and actually, because we proceed the current permutations, so the current index is not necessary anymore, right? So if the current permutation, the length equal to the input length, it means we're done now. So as you can see, we go down the tree. So as soon as we reach the point when the current permutation length equal to the input length, and when I push these permutations, the current permutations, okay. Okay. Let's say I'm gonna push it to all. Push the current permutations. Okay, and return. Return means we come back to the previous recursive call, right? If it is not the case, then it means we still have to add more character to our current permutations, right? So if it comes here, we need to determine which is the current character that we're considering. So that current character is equal to, so we can, the current index is actually the current permutation length. So for example, when the length is 2, for example, then when the length is 2, right? So in the next call, the next character we consider is 7, right? So its index is actually 2, right? 0, 1, 2. Okay. So current character, this one. Okay. So it's obviously that there are two cases here. So if case 1 is a number, K2 is a character, right? So how about doing something like choices? It's an empty array, right? If the current care is when I use variable expressions to determine whether it is a character or a number, I can see, okay, if it match this character, I'm gonna push in the choices here, or whether you can concat. Concat is probably one let's say, okay, if this is the case, choices push. I'm gonna push the current character and current character uppercase, right? To uppercase. Okay. If it's not, else, then I'm gonna push. I mean, it's a number. I'm gonna push current care, right? This is a little bit verbose. It's something that we can refactor, right? So this is the same for two cases. So we can just move it outside. So okay, two choices. So for each number, so for each permutations form, current permutations, right? We want for the current permutations, we will iterate to every choices here, right? So we add the choice to the current permutation to build up our permutations. So for like choice of choices, okay, I'm gonna add my choice to current permutations. What choice, right? This will be a new string, right? So after we have a new permutations, we will recursively call the functions passing strings the new permutations and all, right? So we want to go build up as soon as this is the case when the length of permutation is equal to the length of input, right? And we're done with one path. So after done with this one, I probably want to reverse the permutations to its previous form. So for example, AB7 here we add C, but when we come back here, I want to remove the last character from current permutations. So how to, let's say, not I'm gonna use concat probably. ABC for example. No, slice. For example, its length is 3 here. So it's like 0 to 3 still 2. Okay, so it should be permutations will be equal to permutations slide 0 to permutations dot length -1. Okay, this will remove the last characters, return a new string assigned to permutations. Okay, so that here we come back here and we can go for another choice here. Can go down to the right again, right? So yeah, that's it. After all, I will return the all. Okay, let's run a test. Just 10 4. Okay, works. Let's make sure that it is running our implementations. Okay, it actually works. So that's it for this video. So thanks for watching. See you in the next one.